Hey everybody, welcome to our lecture on the Cathedral and the Bazaar. This is a literary lessons lecture, so we're taking an essay that was written quite a while ago, and we're going to talk about the various lessons that are involved and that come from this essay. So here's a picture, so to speak, of the essay. It's actually not really a book. Like I said, it's an essay that was written a while back by a guy named Eric Raymond. This is what Eric Raymond looks like. He's a very unique individual. If you want to see how unique he is, I recommend that you go and check out his website. He talks all about himself and all about the various things that make him unique. We're not going to delve into that. This lecture is not to talk about Eric Raymond and his personality and all of his interesting quirks. This lecture is actually to talk about what he created when he wrote the Cathedral and the Bazaar. Anyways, let's get moving on here. All right. So some of the interesting things about him, just to wrap up this little slide here, are you might want to check out what it takes for you to get him to visit you. He's got some interesting little requirements there, and also check out some of his personal data. He has a long history in software development. Goes all the way back to, as you can see here, 1999 when he wrote the Cathedral and the Bazaar, and also much earlier than that. He's been around since the early days of Linux and Unix, and he's contributed a lot to the world of open source software development. All right, so one of the first things that he introduces in this essay is the concept of two different models for software development. And this is in particular free software development, right? Open source software development. So the first type of model is what's called the Cathedral model. And this is where you have sort of one big repository of information, one big set of source code that's available when every software release version comes out. It's developed between releases, and this is the key difference between the next one, which we'll talk about in a sec. It's developed by a key set of developers. Okay, so some examples of this are things like Emacs, the compiler GCC, even like early versions of Chrome when Chrome was open source. And it was based on other browsers in the past, you could consider to be run in the Cathedral model, right? Because you had this restricted or exclusive group of developers that were working on it. Gradually Chrome has become more and more owned by Google, so to speak, so you can't really do it that way. But there are true open source software things that are out there that operate under this cathedral model, where you have just a few people that have access to the source code. Then you have something that's called the Bazaar model, and this is not bizarre in that it's like bizarre, but Bazaar, right? I guess my web captioner thing got it right the first time. So Bazaar as opposed to, okay, now it's all messing it up. You can see it on the slide, all right? The Bazaar model is where you have your source code. It's in a big repository, just like with the Cathedral model, but it is essentially open to anyone who wants to work on it, right? There's not this exclusive set of developers that have special permission to work on it. Like, anybody can check it out and they can work on it and they can make changes to it and improvements and so on. So an example of this is GIMP, which is one of those fun recursive acronyms that you see in the world of Linux. It stands for GIMP is an image manipulation program. So it's basically a freeware version of Photoshop. It's actually quite powerful. I don't do much with Photoshop or anything like that. If I did, I probably would just get GIMP, although being a a faculty member at University of Michigan, I have access to Photoshop for free, so I'd probably just use that. But anyways, if I wanted free image manipulation software, GIMP would probably be the place to go for that. All right. A little bit of background here on Raymond before we actually get into the lessons. He, first off, early in his career, when he was starting to formulate this essay, noted that Linux, the operating system, was remarkably successful. Okay, and he wanted to take the principles that he saw that made Linux successful and apply those to his own project. So he was working on a version of offline email access. I think it was called Fetch Mail. All right. So what he did is he took that previously written open source software, he modified it a little bit, put in his own little tweaks and things, and then he released it out into the wild to see what happened. All right. And so, as he was building on this initial success that he saw in Linux, he ended up creating this, successful product. And then also this essay that he wrote, The Cathedral and the Bazaar. All right, so now let's jump into the 19 lessons that are there. All right, so a lot of these lessons sort of overlap with each other. We've seen that in quite a few of our lectures in this class where, we have this bulleted set of points and they actually, some of them interleave with others and so on and so forth. But the essay has, specified that there are 19 lessons, and so we're gonna treat the essay, as it was written. All right, so the first one is that every good work of software starts by scratching a developer's personal itch. All right, so what I mean by a personal itch is not obviously, you have an itch that you have to scratch, but it's like a mental itch, so to speak. Like you're really curious about something and you want to dig a little deeper into it. You want to explore it some more, in particular with respect to software. You might want to see how something works, or you might want to improve something. And open source software is a great place for you to do that. You can download it, you can change it, you can modify it, you can update it, whatever. Lesson 2. Good programmers know what to write, but the great ones know what to rewrite and also reuse. Okay, way back when we talked about user interfaces and user experiences, there was a quote, I think it was from Picasso, that said something along the lines of like, good artists do something, but great artists steal. All right, so the same sort of a concept applies here. Okay, you can be a good programmer and just write software, but a great programmer is going to know what already exists out there and what can be improved upon or reused to essentially make their lives easier. Right? There's no sense in rewrite or recreating the wheel. Right? The wheel has been invented, so why reinvent it? So this is what the author refers to, or Raymond refers to, as constructive laziness. All right, you're lazy to the point of reusing things that are constructive. All right, the next lesson is plan to throw one version away. You will anyhow. And this is actually a lesson that is in the Mythical Man month in chapter 11. And the gist of this, as you can see in the second bullet point, right there, is that you often don't understand the problem until you write a solution to it the first time. Okay, but the first solution is usually full of bugs. It's usually not optimized. There's lots of problems with it. And so you generally want to throw that first version of the solution away and then work on version 2. Version 2 is generally, a little bit too sparse, a little bit too risk averse. And so it really isn't until like the third version where you start getting things really refined and good. All right. Next lesson here, if you have the right attitude, interesting problems will find you. I tend to see this actually reflected a lot in my own personal life. Early on when I first started teaching, and that doesn't mean I don't have a good attitude anymore, it's just that early on when I first started teaching, I was really excited about learning about all the different new techniques and different things that you could do in teaching and the ways that you could improve the craft and all that. And so I had a lot of interesting problems that came up and were presented to me that I was able to work on and use in the classroom. Now that I've been doing it for a while, I think I'm working on almost 15 years teaching now. I sort of have a sense of what I like to do and the types of things that I like to teach and the style that I like to use. But that doesn't mean that there aren't interesting problems that end up finding their way to me. This whole pandemic thing that we're dealing with, we had to transition to a new mode of teaching, and I'm trying always to, better the way that I present things, include different and more interesting ways to engage the people that are looking at my recorded lectures and so on. Even this format here where I have sort of my big self over here and the slides are over there, is different than having this just tiny little picture up in the corner that made it look like I was hiding in a bunker somewhere. Right? So interesting problems will find you. You just got to have the right attitude. You got to be positive, so on and so forth. Okay, the next lesson. When you lose interest in a program, your last duty to it is to hand it off to a competent successor. All right. In fact, this is the way that Raymond got access to the program that he was working on, FetchMail. He knew someone that was working on it, and they had gotten bored with the material, and basically just gave it to Raymond, and he started working on it. All right. Um, I would imagine the same thing would apply to y'all on your projects, right? When you're done with your projects, make sure that you have a competent successor to hand the project off to. If you have a formal sponsor for your project, hopefully that formal sponsor is going to want to take control of your program and continue to develop it. But if you're just working on like a small class project, if you do want it to be developed further, either hand it off to some of your friends so that they can continue working on it, or continue working on it yourself or something. You don't want to just drop it on the floor so that it doesn't go anywhere. All right. Some programs deserve that treatment, right? They're not very good, that you didn't have any success, there's no direction, whatever. So just get rid of them. All right. There was a quote in one of our lectures about, if your product is an economic loser, just drop it, right? Don't pursue a project if it's not going to have any success. But if you think it's going to be successful, make sure you hand it off before you lose interest and just let it, fall apart. All right, the next lesson: treating your users as co-developers is your least hassle route to rapid code improvement and effective debugging. All right, so this is really one of the main lessons that's connected with the Linux development model. All right, if you didn't know, the person who created sort of Linux, so to speak, was this person named Linus Torvalds, this guy right here. And he created, the Linux kernel, which everything is built off of. But Raymond argues that that's not really, the technical kernel achievement wasn't the amazing development of the project. It was actually the development model, the open source model, where you have users as co-developers, that really made Linux successful, because it got people to be engaged. They took part in the quality of the software, and they could see their changes or their recommendations for improvement reflected in the software. So they became a really good resource for debugging and code improvement. All right, the next one is part of the agile development mantra. So all the way back in 1999, Raymond was thinking about this stuff. So this is the release early, release often, and listen to your customers model. Straight up agile development right there. Not much more to say about that lesson. All right, the next one is a rather involved one. It's got a couple of nuggets of information in it. So if you have a large enough beta tester and co-developer base in some open software models or whatever, open source software models, the beta testers and the co-developers are sort of the same people. But if you have a large enough base of people, every problem can be identified very quickly, and someone out there in the mass of people that's working on the software is going to be able to find that problem, and it's going to be obvious how to fix it to those people, given you have a large enough base of people that are working on this. And so this leads to Linus's law, or it creates Linus's law, which is, given enough eyeballs, all bugs are shallow. This is a very famous quote that you might want to just stick in the back of your mind, because this is sort of one of the distilled essences of open source software development. Given enough eyeballs, all bugs are shallow. All right, so if you have this large user base, in fact, it's fairly common that one person will find a bug and then a completely different person will figure out how to fix it. All right, and finding the bug is oftentimes the hard part, right? Figuring out that something is broken, because a lot of the bugs that come about when a final product is released are not very common, right? They're rare. They're hard to discover, first off, and then they're hard to recreate in a lot of situations. So finding that bug and identifying it and figuring out how it happens is hard, and then fixing it sometimes is relatively straightforward. And then the last thing about this lesson that I want to talk about is something called the Delphi effect. And this one says, as you can see, the averaged opinion of a mass of equally expert, or this is the interesting part, equally ignorant observers is a more reliable predictor than a single randomly chosen observer. All right, so the Delphi effect basically says you get more people, given enough eyeballs, all bugs are shallow, right? So it's just a more formal rewording of Linus's law. They both roughly say the same thing. If you have a lot of people, and they don't necessarily, I guess this is where the Delphi effect may differ a bit, is that it doesn't matter whether or not they have an incredible amount of expertise in the area, right? It just requires a mass of observers. Um, they're going to be a more reliable predictor of something than a randomly chosen observer. Okay, and then the last thing here on this slide is a quote, also from the Mythical Man Month. A lot of lessons in the various bits of literature that are out there, both in early software development and also in current software development. They sort of overlap. So, anyways, the total cost of maintaining a widely used program is typically 40% or more of the cost of developing it. Right? Think about that for a second. If you have to maintain software after it's been released, plan on spending 40% or more of the development cost on maintenance. That's a lot of money, especially for a company like Microsoft or Apple that creates entire operating systems. Needs to be a big budget line item in there for maintenance. Okay. And then it goes on with, surprisingly, this cost is strongly affected by the number of users. More users find more bugs. So there it is again, Linus's law, right? More eyeballs, all bugs are shallow. All right, next slide. Smart data structures and dumb code works a lot better than the other way around. So go back to EECS 280 and learn it all again, right? EECS 280 introduced the concept of data structures and classes and inheritance and virtual functions and all that business. This lesson argues that if you have good data structures that organize your software in a efficient and effective way, that you can throw a bunch of dumb code that uses those data structures, and that's going to be better than the other way around. If you have terrible data structures but really smart code, right? So just keep that in mind. Fred Brooks also made a comment about this in his Mythical Man Month book again. Show me your code and conceal your data structures, and I shall continue to be mystified. Show me your data structures, and I won't usually need your code. It'll be obvious. All right, so if you write really good data structures that are clear and the documentation that surrounds them makes it obvious how they're to be used, and the different layers of inheritance and all that makes sense, writing code to use those data structures is very straightforward. But if it's the opposite of that, if your data structures are just a mess and they don't inherit properly and they share behavior and all this other stuff, writing code to make use of those data structures is going to be very difficult and mystifying. All right, next one. If you treat your beta testers as if they're your most valuable resource, they'll respond by becoming your most valuable resource. Or it's kind of obvious, or it's what do you call it, like a self-fulfilling prophecy, right? Treat your beta testers well. Give them access. Give them kudos for finding bugs and for fixing problems and all that kind of stuff. If you do that, if you treat them as your most valuable resource, it turns out those beta testers will follow right along with Linus's law from the previous slide. They'll find bugs, they'll suggest fixes, and they'll become your most valuable resource. So just treat them as such. All right, the next lesson. The next best thing to having good ideas is recognizing good ideas from your users. Sometimes the latter is better. The latter being recognizing good ideas from your users. All right, so there's a quote right here. If you are truthful about how much you owe other people, the world will treat you like you did every bit of the invention and are just being modest about your innate genius. Think about that for a second. So if you're truthful about how much you owe other people, so think about like if you're a manager or something, and when it comes time for your boss, one of the higher ups, okay, you're a manager, but there are people above you, I'm sure, unless you're the CEO of the company or whatever. But when they come to you and say, wow, this is amazing software that you're working on, and you respond with, well, it was really a team effort. It was all my team's work. They were really hard. They were really diligent. The world is still going to treat you like you did every bit of the invention, and you're just being modest about your innate genius. Whether or not that's a good thing, that's kind of how it goes, right? I try not to take any credit for when I'm working on projects, especially with student teams. I always try to go, oh, it's all the students, right? They're the ones that did the work, and which is absolutely true. But people still come to me when they have questions about stuff, mostly because they perceive me as like the authority on something. And in some cases I am, right? But really it's the team that did all the work, and they put in the effort and they created the product. So in that sense, I'm following along with this lesson. I'm recognizing good ideas from my users. I can't really call my students my users, but when my students do amazing things, especially in class, I try to promote that so that they can get credit for their hard work. I don't take credit for it, but people still, for whatever reason, continue to contact me and say, "Hey, I heard about your whatever class." I'm like, well, it's really my students. But so I don't know I'm sure there's some psychological phenomenon that causes people to do that, to give credit where it's not necessarily due. But keep that in mind. It's not a bad thing to give others credit. They'll see that you're doing it for them. Just don't pretend like you're the one who's working on things if other people are doing it. All right. I guess there is some element of, you are a good manager and you provided them the appropriate environment to flourish and so on and so forth. If you adhered to the principles of the Peopleware book, for example. But if it weren't for your team, you wouldn't be anywhere. It's a team effort. All right, next lesson. Often the most striking and innovative solutions come from realizing that your concept of the problem was wrong. Okay? There's a quote from way back in my past. I'm not sure exactly how it goes, but it's something along the lines of, it's easy to learn new things. What's hard is to unlearn things that you thought you already knew, or something along those lines. So basically, it's difficult to try to learn something that you had thought about in a different way and learn it in a new way. But the thing that this lesson argues is that when you do that, okay, when you realize that your concept of a problem was wrong, you oftentimes lead to very sort of eye-opening discoveries, okay? If you sort of like think about things in a more creative way, like, oh, you know what? I never really thought about the problem that way. Wow. Well, then what if we do this? All right. So trying to think about a problem from a different perspective, trying to engage, all your senses to try to really dig into the problem and think about it from different directions. Think out of the box, so to speak. A lot of times, that leads to more innovative solutions to a problem. All right, the next lesson. Perfection, and this is with respect to design, is achieved not when there is nothing more to add, but rather when there is nothing more to take away. So this is actually connected in a sense to one of the lessons from the Design of Everyday Things book, and also I think one of the UI UX lessons from I think it's Nielsen's heuristics. Where essentially simple is better, right? You don't want to fall victim to code bloat. You don't want to add a whole bunch of complexity to your software so that it's no longer usable. You don't want feature creep. You don't want featureitis, that type of a thing. You want to have just the right amount of functionality in your software. There should be nothing more to take away. And that's when you know that you've reached perfection in design. All right? When your code is getting both better and simpler, that is when you know it's right. That's what that quote right there is telling you. All right, and this is attributed to Antoine I'm not even going to pronounce the rest of that French stuff, but that's who created that. All right, next one. Any tool should be useful in the expected way, but a truly great tool lends itself to uses you never expected. So I don't have a lot of really awesome examples for this in the world of software, but I do in like the world of construction. And I always get in trouble for this too. Like when my father-in-law is a contractor, right? And he builds houses, he hires crews and have them build all sorts of stuff, whatever. He always gets mad at me for using tools in ways that they weren't supposed to be used. So for example, many times the phrase has left his mouth that, drills don't make good hammers, but I would argue that they do in certain situations, right? Like I have an electric drill in my hand, I'm working on something, and I need to just get that little thing in just a little bit farther. I need to get something, just boom, boom, boom with the handle of the drill, right? That's a truly great tool. I don't know. I use it as a hammer. But there are also lots of other things. I don't know if you probably don't know what a pry bar is, but it's this sort of like, it's kind of like a crowbar, except it's flat. And well, crowbar is like this thing that looks like a big hook, and you hook it onto something, and then you use leverage to like pull out nails and things like that. Well, a pry bar is roughly the same thing, except it's flat, and so you can do all sorts of other stuff with pry bars. You can use it as a hammer, but you can also use it to like slide in between things and like pull things that are apart. Like if two boards are nailed together, you can slip it in between the boards and then pry them apart. Like you can do, I guess it's a pry bar, so that's prying, but whatever. There's lots of different things that you can use just a simple tool like that for. So any tool is useful, and it's in the thing that it was designed for, but great tools you can use for a lot of things, and things that you didn't expect. All right, the next one: when writing gateway software of any kind, take pains to distribute the data stream as little as possible, and never throw away information unless the recipient forces you to. All right. So distributing the data stream as little as possible, that's obviously if you shoot out a whole bunch of data all the time, that's going to start clogging things up. But never throw away information unless the recipient forces you to. That's sort of like the whole mindset now of modern computing, is just keep everything, right? You never know when you might need it. As long as you have the storage capabilities to hold it, why not keep it? I'm not sure if Google ever thought way back in the day that it would be a good idea to keep every single email that people send and receive, but they did it, right? They essentially got rid of the delete mechanism in Gmail, and the default method for when you were done looking at a message was to archive it. Well, they probably actually did have this in mind. Now they use those archives of email to do all sorts of stuff. They might not have had the technology at the time, but once they create the machine learning algorithms and all the different ways of processing that large quantity of data, they can actually dig through that data and gather lots of insight. They can figure out what your shopping trends are. They can figure out what kind of ads to serve up to you, all that kind of stuff, as long as they have the data. So if you have the space to store it and it's not going to make your software super slow and inefficient, don't throw anything away, because you never know when you might need it. It's sort of the digital hoarders mentality, right? Okay, next one. When your language is nowhere near Turing complete, and I put that in parentheses because that's not really the important part of this quote, in my opinion, syntactic sugar can be your friend. So what's syntactic sugar? It's basically software syntax that is very sweet and tasty, but isn't necessarily going to make your software more efficient in the long run, right? The whole point of this syntactic sugar is that it's more important for a language to be convenient to use than cheap for the computer. That wasn't always the case. Way back in the day when software was first invented, or not, software was invented, when software became sort of a prevalent model of writing code for computers to run, those computers did not have a lot of memory. And so the software that was written had to be very tiny, couldn't take up any space because there just wasn't any space, right? And so sugar, syntactic sugar, syntax in a language that made it easier for people to write code, was a burden because it took up extra space. But that's not the case anymore. Now we have as much space as we essentially need, unless you're writing drivers for embedded systems or something. So now we need to focus on what makes it easier for us to program. So we can create incredibly graphic, user interface intensive programming environments that generate source code for you based on pictures that you slide into place. So languages like they're actually languages for kids, like Scratch, for example, is one of those things where you put these little software like puzzle pieces together, and when you hit run, those puzzle pieces in a sense turn into code, which is then executed by the system. I think it turns into Java or something like that. So those little puzzle pieces are really easy to manipulate. You can teach a third grader how to write software with this Scratch programming language, but they don't have to understand any of the complexity of the computer and the software underlying language, Java, any of that. They can just program with those little puzzle pieces. So it's easy to use, but it's not very efficient. Okay. Next lesson. A security system is only as secure as its secret. Beware of pseudo secrets. So this is connected to the whole concept of security engineering and making your software secure. all that kind of stuff. The second part of it, I think, is more interesting than the first. The first part of it about being only as secure as a secret is fairly obvious, but beware of pseudo secrets, right? So pseudo secrets are things like happened in this little quote that you can see here. So in fetch mail, the passwords were stored encoded in a way that made it hard for you to see them. However, the source code for fetch mail had a decoder in it, right? It had the algorithm to decode passwords inside of the source code. So all you had to do was get the source code for fetch mail, and you could decode somebody's password that was stored in what's called their RC file, right? So the RC file stored an encrypted whatever version of the person's password, which is fine, right? That seems like it's a secret because it's encrypted, but the lock to open, or the key to open up the lock, so to speak, is sitting right there in the publicly available source code for fetch mail. So it's actually a pseudo secret. Another example of a pseudo secret is security through obscurity, right? So an example of that is a website, for example, that contains sensitive information. If the website is just publicly available, like anybody can get it, as long as they have the link, that's not necessarily secure. Google has that as an example. If you're going to share a document on Google Drive, you have the option to share with anyone who has the link, right? So the link is fairly obscure. It's just a bunch of, it's a beginning thing like drive.google.com, and then it has a bunch of random characters at the end of it that no one's going to remember, right? It violates one of Nielsen's heuristics. But if somebody knows it, right, if they copy and pasted it to their friends, it's no longer a secret, right? It's a pseudo secret. All right, next lesson. To solve an interesting problem, start by finding a problem that's interesting to you. This is essentially lesson number 1, solving your itch. Okay, this one just has another quote that's associated with it that I thought you might find interesting. The best hacks start out as personal solutions to the author's everyday problems and spread because the problem turns out to be typical for a large class of users. So generally, if you want something to be better, there's other people out there that want it to be better as well. Okay, so it's connected to lesson 1. Finally, the last lesson from the Cathedral and the Bazaar. Provided the development coordinator has good communication skills, at least as good, a good communications medium, at least as good as the internet, and everybody does now, and knows how to lead without coercion, so that's another peopleware example of how to be a good leader. Many heads are inevitably better than one. Okay, and this is in direct contrast to Brooks' Law. Brooks' Law is one of those statements from the Mythical Man Month that's become very popular. And it says that adding developers to a late software project makes it harder, or it's not harder, later. All right, so you can't just add more people to a software project and expect it to be done more quickly. That is a quote that pertains not necessarily to open source software. In fact, it shouldn't relate to open source software. If you're working on software in a big company like Microsoft or whatever, where everything's closed down and very restrictive, if you add more people in an environment like that, it's going to take longer to finish a project because of the fact that those types of environments typically require everyone to communicate with each other. And so you're going to get stuck with all of these different paths of communication, and you're going to get this like messy, fully connected, awful graph of people, and development's just going to grind to a halt. However, in the open source software community, all right, as long as you have a good medium of communication like the internet, so forums or Trello or whatever, some way of getting all sorts of bug reports and bug fixes centralized in one place. And then also, as long as the coordinator of the whole project knows how to lead without coercing anyone or forcing anyone to do anything, the more people you add into that type of an environment are going to be better than one. Okay, so that directly opposes Brooks' Law. The reason being is that people in an open source software environment are not going to need all to communicate with each other. They're not going to have a management hierarchy that they have to operate under. They're all just sort of out there in a very Bazaar-like environment, and they're going to be able to freely develop on their own and look at problems that other people are having. So it's a totally different type of development model that works for this kind of software. All right, so what are some necessary preconditions for this Bazaar style of model? The first, the code has to run before you release it into the Bazaar. Okay, Bazaar. I know that for those of you that are reading these words down here, these words are not super accurate with respect to Bazaar and Bazaar. See, it even messed it up there. So anyways, you can't, in this type of a model, just release broken code out and expect people to fix it. It needs to run. Okay, if you release code that's broken, it's just imagine like, giving a huge group of people a pile of building materials and expecting them to build a house. All right, the level of coordination that would be required to organize all those people together to get a working version of that house up that can then be iterated on by the masses is too much. All right, it's impossible for a marginally organized group of users to go out and organize code that doesn't run in order to get the whole process started. So you have to release code that runs first before you send it out into the Bazaar for other people to work on. All right, the next one is that the code must convince others that it can be evolved into something great in the foreseeable future. All right, they can't think that, oh yeah, maybe in 100 years this will, no, it has to be the foreseeable future. They have to see that this thing can go somewhere, that it has the potential to be great, in order for them to get engaged with the process, in order for them to have buy-in, right? And then finally, the project coordinator has to have good people and communication skills, as we've probably seen all throughout this year. This is pretty rare for people to have good communication skills. Okay, so if you're going to be the person that's running one of these big things, you have to be an excellent manager. All right, so that's it for the Cathedral and the Bazaar, the 19 lessons. Now, if people ask you, have you ever seen or ever heard of the Cathedral and the Bazaar, you can be like, oh yeah, I heard about that in my multidisciplinary design course or in my senior design course or whatever. Okay, so yeah, that's all I got for today, and I'll see you around next time. Bye-bye.